everybody. Welcome to another episode of vBrownBag, the weekly IT video podcast where we bring you experts in the wide world of technology, talk about their favorite topics, nerd out, have some fun, ask some good questions. And we've got a security engineer on this evening, and we're going to talk about building a security data lake, in parentheses on AWS. And our presenter this evening is Richard Fan, who is coming to us live from Hong Kong. Good morning, Richard. How are you doing this morning?
Good morning. I've just wake up and not very sleepy because I have a coffee. Yeah, so hopefully I can give you guys interested.
Awesome. Absolutely. Yeah, this is going to be a good talk. Before we get into it, let's do a couple of housekeeping show notes. Get in on the conversation. If you are on Twitter, you can @vBrownBag, and I will be paying attention to your questions on there if you have any for Richard. If you are in the live studio audience, feel free to post a question in the chat channel, and I will ask them of Richard if they're good. They better be good. Okay. If you want to follow Richard on Twitter, he is @RichardFan1126. You're not on there a lot, are you, Richard? I don't see a lot of posts from you. You seem to be more of a lurker than a hanging out person.
Oh, I didn't use Twitter much, but I do write blog posts. You may see my blog posts in DevTalks2 and also Medium. And also I'm more active in LinkedIn. The handle is the same, so you may connect me in LinkedIn.
Awesome. Okay, and you'll have your contact information in your slides, I'm assuming, yeah?
Yeah.
Perfect. Awesome. Okay. Well, in that case, I will shut up and stop the share. And you now have the power, sir.
Yeah, sure.
All right, we can see your screen.
You guys, okay. So today I'm talking about building security data lake. And talking about data lake, I think many people already heard of it or know about it. What was that? But when we talk about the relationship between security and data lake, or even when you type security and data lake at the same time on Google, the result you may get is how to build your data lake securely, how to make sure your data lake is secure. But today I'm not going to talk about this. I'm going to talk about building a data lake specifically for security, for the security of your system, the security of your company, and some concept around it, and what I've learned when I built a security data lake in my job. But before that, let's talk about myself. My name is Richard. I'm a security engineer from ExpressVPN. And ExpressVPN is one of the leading VPN provider in the world. And we believe internet is free and open, and the user should have the power to shape their own online experience. So today we provide a secure network of VPN server to over 4 million of our users, helping them take back control of their online experience and protect their privacy. And coming back to myself, I'm also a AWS Community Builder. I'll see myself as a builder and technology advocate as well. I love to explore new technologies, especially some new AWS servers, and help other people succeed. I always share my experience on AWS through blog posts, talks, and open source projects. So you may follow me in the Dev2 and Medium, and also my GitHub repository. And also, as I say, my LinkedIn handle is also RichardFan1126. So you may connect me as well. And being said that, I love to share my experience, and this is also why I'm here today to talk about security data lake, and hopefully it can help our audience here to understand more on this area. Before talking about the data lake itself, let's talk about what is security data. So I have an example. So let's say we have a building now, we want to protect it. So how do we do it? Well, what do we need? So we need to know, let's say, how many doors does it have? So does all the door have the lock? And so if the door has a lock, then who can access the door? And how the people access the door? Do they have access card to it, or do they use the key, etc., etc.? Do we have CCTV? And where are those CCTV? Also, do we have security guard? And what are their duty? So many things to protect the building. Knowing what component can help the security of your building. But more critical is the data they generate. So you can imagine if we have a bunch of CCTV, but nobody ever look at the footage, or if we have a SS card system, but we are not collecting the SS card when the employees leave the company. So when the ex-employee use their expire SS card to go into the building, but nobody noticed that unlock record, or if the security guard noticed a suspicious person, but when you ask him the next day, he already forgot it. He cannot give any information about that suspicious person. So without knowing all this information, you cannot successfully protect your building. And coming back to the computer network of the IT world, we also have many security logs from our server, workstation, network equipment, etc. Even the cloud, we have so many security logs generated. And why do we need the security log? Why those log is important for us to protect the system? There are hundreds of thousands of reasons, but I'll list out four that is more important. I think is more important. First of all, detecting threat. So if you want to protect your system, the most important thing is you need to identify what threat is it. Are you under attack? Is there any loophole inside your system? We're not just talking about external threat, like an attacker gaining some unauthorized access, something like that. But we are also talking about internal threat. For example, maybe a careless system admin mistakenly disable the firewall. It will not pose an imminent threat, but you need to capture this event and notice and remediate it, re-enable the firewall. This is what security loss can give us. Incident response, when we are under attack, you first need to know you are under attack. Without knowing you're under attack, it's just trash talk. And you need to know where the threat expanded to. If somebody gained unauthorized access to your server, did they go into another server through your network? You need to know how many components are affected. And recovery, after the incident, you need to recover your system. And you need the security log to monitor to see if your system is really going back to normal. And talking about normal, you need to have the security log, not just when you are under attack. You need to keep your security log and keep monitoring it, because you need to know what normal means in your computer system. Every system are different, so you need to understand how your system behaves. And collecting log is the most important way to do it. And compliance, I think even if your company is not very serious on security, you will be serious on compliance, because if your company is under regulation, every year or every quarter, the auditor will come and ask for evidence. If you are not collecting your security log frequently, you may be unable to give the evidence to your auditor to convince them you are compliant throughout the year. And vulnerability management, I think this one is not really directly related to security log, but it helps a lot, because as I say, you need to know how your system behave, what is normal means in your system. So when the vulnerability result comes, the most common finding would be like, okay, your server has port 22 open, has RDP port open. But with so many similar results, you need to know how should I remediate it. By looking at the log, you will see how the server behave. For example, this server is opening port 22 because your web admin actually using it to access the web server for debugging. Then you know that this one you don't need to remediate it now, because it may break the work of the system admin. And for other server, you may look at the security log and see, okay, actually there's no one using the RDP port, no one using the SSH port. Then you can confidently block those port and remediate the vulnerability. So it is really helpful when you are doing vulnerability management and also remediation. So security log is important, but how do we capture it? There are many ways to capture log. The most common way I would say is this two. The left-hand side, storing, or I would say, or not storing locally, is when you start your company or start your system. Security is not always the first priority when you build something. So most probably you're using the default setting. For example, if you have an AWS account, without turning on CloudTrail, AWS already collect the CloudTrail log for you for free for 90 days. You can always look back your CloudTrail log for the past 90 days. And this is turned on by default. If you install Apache server, most likely there will be default logging SS log in maybe /var /log folder. They are storing locally. Most people have it because it's the default for many systems. But just storing it is not a very good security posture because, first of all, when your system is under attack, maybe the attacker also deleted the log because it's stored locally. It's in the same machine. If they can gain access, they can delete the log as well. The second part is if you're under attack, most probably you are also freaking out and you just forgot how many servers your system has, where are those logs located, and you may take some time when you are doing incident response to gather all the logs and correlate them. The second approach is if the company is more serious on security, they will start looking at some solution, and most likely is the SIEM solution, security information and event management. There are many SIEM solutions like Elasticsearch, Datadog, Splunk, Sumologic, many, and they have a very strong capability for you to easily ingest different security log. They have many support, like if you have AWS, they can help you ingest your AWS log. If you have a Windows server, they can help you ingest Windows event. Then all the logs will be centralized. And they have many beautiful dashboards that you can just deploy it with one click. And with those dashboards and with those data, you can have a clear view on how your security posture is. And they also have many built-in alert rule that you can turn on. And by ingesting the data and analyzing the data, they can help you identify potential attack in your system. And they also have a strong query capability, so you can always write your query and play around with the data. It's easy to use. But the problem is the growing amount and complexity of security log. I would say especially during these few years during the pandemic, there are more and more companies going to cloud. Like they need to have virtual desktop because every employees are at home. They need to have some collaboration tools to find many cloud solutions to help them stay productive during the pandemic. And also the shift left culture. So maybe 10 years ago, if you ask me if I am an application developer, my only duty is to write code. I will pass the code to the system admin and to deploy it. And they will help me spin up the server, monitor the server. So maybe if you ask me at that time, I may answer you, I have 3 AWS accounts because it's just development account, testing account, and production account. And all our product is in that account. But now you may easily have 50 or 100 or even 200, 1,000 AWS accounts because every team have their own account. Every team are responsible for their infrastructure. And also the amount of security log you have will grow because of the more and more account you have. And also, as I say, adoption of cloud, because we use more and more cloud servers, the amount of log generated is increasing as well. And also the complexity of log, because different cloud provider have different format, have different ingestion of the security log. So you need to cater of the complexity of the security log as well. I can see two common approach to deal with this security log flooding. First of all, I would say many company or many people will just drop the security log that they think is less important, because the Elasticsearch cannot scale up indefinitely. They don't have enough money to ingest so many logs. But I would say this is a misconception. One of the biggest mistake I always hear is we don't need the security monitoring on the sandbox account. The rationale behind is there's no production data, is not our main account, even though the attacker goes in and delete all the resources, is not a big deal. So we don't need monitoring on our sandbox account. But after taking my OSCP, OSCP is a famous offensive security certificate. So after taking it, I regret how stupid I was when I am a secure system admin to think sandbox account doesn't need monitor. Because if you think as a hacker, you will understand most of the hacker will not attack your production server directly. They will find for low hanging fruit first. And most probably the low hanging fruit is your sandbox account. Maybe IAM misconfiguration. Maybe your developer also think the sandbox account is not a big deal, so they commit the access key in the GitHub publicly. Maybe that access key is an admin account. The hacker can go into your sandbox account, and guess what? Maybe there is a production credential in the sandbox account as well, because some developer may test the production code in the sandbox account without removing the production access key. Who knows? If you only
worse,
monitor
the IAM credentials are admin.
yes, that's true. Or maybe cross account role. Yeah, the sandbox account is really creative, so you cannot predict what will happen in the sandbox account. So if you only have monitoring on your production account, you will be difficult, if not impossible, to find out where your attacker come from, because the sandbox account is the first foothold to go into your system, and you have no monitoring on sandbox account at all. So this is actually not a true statement. There is not an option for you to drop so-called less important security log, because every security log is important. It is just you can use it now or you can use it later, but they are equally important. The second approach is I can see some companies, they have, I would say, I can't imagine how can they have unlimited cash. They just don't care about their budget. So they can scale up their Steam solution, their license unlimited indefinitely, and send all the security log to it. But it is still not a solution, because Steam is not an ultimate solution. So there are several reasons. First of all, as I say, too expensive. No matter how much money you have, if you store your log, you are storing it, let's say 1 year or 2 years, so your security log will stack up. You have more and more security logs there, and you cannot catch up with the increasing amount of the security log as well. So at some point you will have the limit that you cannot stream log anymore. The Steam solution always calculate your license in gigabyte, like maybe per 100 gigabyte, per 500 gigabyte. But believe me, this 100 gigabyte, if you have 2 or 3 firewall and you stream all the firewall event log to your Steam solution, maybe it is easily to use up that quota, because believe me, firewall log is really crazy. The amount of logs is crazy. The second thing is the retention period as well. because SIEM is designed for you to query the data, to analyze the data quickly. So they have a very hot storage tier that you can retrieve the data frequently. But this is very expensive. So they will always suggest you to have your retention period. Like after 90 days, just delete the data. If you don't have any other storage to store those data, then the data is gone. And as I say, compliance, if you want to gather evidence to the auditor, you log into your SIEM and you realize, okay, the data is gone. I always have this issue with some company that the auditors come and we realize, okay, the data in the SIEM is already gone. We have no way to retrieve it back. And also, it's difficult for you to do baselining because, as I say, how normal means in your system is depending on your system. Whenever you have some new threat detection rule, you want to do a baseline, you rely on a long period of security log in the past to do the baselining to define what is normal in your system. So you need a really long period of security log to do this. And also it's difficult to integrate with other data processor because SIEM is not designed as a data storage, although some of them have the export features that you can export the data to other place. But in terms of like doing machine learning or data analytics, you cannot easily plug your customized app into SIEM to get the data directly. You always need to write your middleware or connector yourself. So it is an obstacle when you want to use those data from SIEM. So now this kind of issue take us to data lake. Data lake is not a new technology. Is in the mainstream for, I think, is already more than 10 years. So I think many people have heard about data lake, but still we revisit what is data lake first. So data lake is an architecture for you to store data in a large scale. It's a centralized data repository. So it's designed for you to get the data on different purpose, like when you want to do analytics, machine learning, data discovery, data lake is the point where you can find all your data. And data lake is not just about storing data in a cheap way. It's not just for storing data just because you want to store it. It's an architecture about turning your data into useful data. Data lake is not just saving data, it's to make your data meaningful, useful to you. So data lake is not a data archive. I heard of many people saying when they consider the cost of storing data, they will, let's say it's S3, they will immediately think, okay, S3, we can have lifecycle policy, we can move the data to Glacier. But wait a minute, why are you storing data to Glacier? You need to think about why you need to store your data to Glacier. Is it because of compliance issue? Is it because you want to revisit the data 6 years later? If not, then why are you storing the data to Glacier? If you store the data because you want to use it, then you need to think about how you make the life cycle of your data. It is not just about collecting the data and store it somewhere in your backyard. Data lake is talking about storing the data for you to easily access, easily use it. So I'll simply say it's not just a data archive, because data archive, you can find many different solutions. You don't need to build a data lake. But in the other hand, it's also not a database. If you think too much on how to structure your data, how the schema looks like, then it will become an obstacle for you to ingest different security logs. So I would say, think about how to index the data, but don't think too much about how to write the schema, how to write a table for those data. Just ingest it first. Because data lake is talking about getting data, no matter it's structured, unstructured, or semi-structured, whatever. Because data lake is already very mature, I would say. There are many ETL, extract, transform, load solution out there. You can always get the data first and then do the machine learning, data wrangling. And even on AWS, we have AWS Glue can do the job for you. So get the data first. Don't think too much on the structure of the data. And these are data lake, but what is security data lake? How come I have a separate topic on building data lake for security? There are several reasons. First of all, is the use case. Security data, you gather the security law is all about threat detection. And I would say threat detection is slightly different from getting data from some traditional data lake. Traditional data lake, we see many use case, business side, business use case, like using the data for business decision. Maybe you have some marketing event, you want to explore the data, find some creative way to do your marketing event. So it's all about creative. You can do whatever creative for your data for business purpose. But security is another story. You cannot play experiment on server A. I monitor server A today, and tomorrow I will focus to protecting server B. No, you cannot do this. Security is about protecting your entire system every day. So it's threat detection is a more repeated and boring experiment. So every day you need to do the similar thing, find some potential attack. It's like a hide and seek and maybe cat and mouse game. There is a repeatable action for you to inspect the data. It is not a creative, but you still need some creativity on doing threat hunting. I'll talk about threat hunting later, but compared to business decision is more boring. So event context is also important because attacker can have a different attack path. Maybe they have a long attack path until you realize your computer system is under attack. So every security log matter. And if you want to connect the dots regarding the potential attack path, you need to have context of your every security log. Let's say you have an unauthorized access on your S3 bucket. You see the log, the source IP is just a number. You need to know that number, that IP address. Is it an external IP or is it an internal IP? If that's the internal IP, what's the computer name of that IP? If you know that, then you can easily go to that server to find that log, to see what is the attack path. So you need to have the event context of every security log for you to do the threat hunting, threat detection. And the next reason I think is the most important differentiator between traditional data lake and security data lake is the speed. So you can have your business decision in a week, in a month. It's totally fine to have a month-long meeting to find out the data and come up with a business decision. It's also totally fine to use 1 week or 1 month to gather the data to create your new marketing event. It is totally fine for you to use 1 month to gather the data. But it's not okay for you to use 1 week to realize there is an attacker deleting the data in your S3. So at that point, you may already lose your job, or maybe your company is collapsed already. So yeah. So when you gather the security log, if there is potential threat, you need to be alerted immediately or within 15 minutes. You cannot have your data lake doing data mining every day or every week and then realize, okay, yesterday we have an attacker, but now the data is all gone because we cannot catch the attack fast enough. Also, it's not just about speed of detection. It's also about agility. Let's say we are if we are still under log4j, let's say, now we are waiting for the patch to come. So are we doing nothing just to wait the patch? No, we need to figure out, is our system being attacked because of log4j? So to do that, we need to write a new security alert, new security detection. Maybe you need to pull in some new data source. You need to deploy the security alert on those data. So we cannot take 1 month to write that detection rule. We cannot use 1 month to gather the data and also deploy the detection rule. We may need within 1 week or within a day, we need to deploy the new detection rule. So the agility is also important. It's all about speed when it comes to security. So yeah, I've talked about many ideas. So how do we start? So first of all, data. If you don't have security data, then it's nothing. So you need to identify all your data source. It may be from your asset inventory. You need to know how many components in your system, in your computer network. Maybe also cloud service, what cloud service you are using. And then you need to understand what those components can provide you. Because if you look deeper into some of the new cloud service, you will notice that audit log is not always available. So you when you decide what cloud service, what security log they can provide is also one of the concern you may need to think about. Also identify the ingestion method, because different solution may have different method for you to get the data. If you have firewall, if you have a switch, most likely they are using syslog. If you are using AWS service, most likely the log is in CloudWatch log. So you need to figure out how to get those data. And then you need to evaluate your situation. It's all about people and the current stack you're using. So engineering, do you have security engineering team like my company that you can dedicate time to build the solution for security? If you don't have enough engineer, then maybe SIEM solution can help you as well, because we're not talking about getting rid of SIEM at all. SIEM can also fit into our security data lake. So evaluate your engineering capability and decide how much custom effort you need to pay. Threat hunting capabilities, because security log, you need to know how to use it. You need to understand the risk landscape of your company and decide what threat detection rule you need to write on top of the data. And threat hunting is an experiment process, repeat, and again and again. So do you have a dedicated team to do threat hunting, to inspect the security data, to experiment on the threat hunting rule? Also SIEM options. Do you currently use SIEM? How do they measure the license cost? Because I can see two main measurements. One is the ingestion amount, one is by the storage amount. So these two options will affect how you design your security data lake. Most specifically, how SIEM fit into your security data lake. So there are several integration on SIEM, how to fit into security data lake. So I will talk about security data lake, the detail in a few slides using our example. But let's take a 30,000 feet overview first. These two diagrams are similar. The only difference is where do we split the data source. So on the left-hand side, you can see source split is really simple. It's just, let's say you have a firewall using syslog to send data to the SIEM, let's say Elasticsearch. Maybe you can configure the firewall to also send a copy of log to your data lake. This is one of the options for you to get data from the data lake, but also having visibility of the data on SIEM. The right-hand side, the connector split is a little bit easier because most of the theme solution have the connector shipped with it. Let's say Elasticsearch, they provide Logstash for you to ingest log. Logstash has a feature that you can specify more destinations than just Elasticsearch. Maybe you can use Logstash to ingest the data, but also send a copy to your data lake. So it is similar, but the idea is just send 2 copies, one to the data lake, one to the theme. This is a more serial solution. The left-hand side is theme to data lake. I would say this is the easiest to start if you have theme or if you're planning to have theme solution. Let's say you have an Elasticsearch. So you can use Elasticsearch as usual to ingest the data. But instead of storing the data just in theme, you can export the data from theme to, let's say, S3 for your long-term storage. And whenever you want to revisit the data, you can always go to S3 and query it. The upside is you don't need to write your ingestion method because the connector is provided by Logstash or Elasticsearch already. You don't need to worry about how to get the data. The second thing is because theme has structured your data already, is well organized, you don't need to worry about how to structure your data lake, how to structure your S3 folder structure, how the data looks like. Is it in the right encoding? Is it compressed? Do I need to uncompress it first? Theme will handle it for you. The right-hand side is in reverse. It's first going to data lake and then to theme. This is how we build our own data lake. We have an engineering team, so we can dedicate our effort to building this data lake. We can build our ingestion pipeline to ingest different method, different data source to our data lake. And then also we can build a filtering capability to apply some rule on our data lake. So now we are just sending some high value or interesting security log to the theme. So it is really reducing our cost of theme usage because we are now not spending money to theme just to save garbage. Because whenever we send the data from data lake to theme, we know that those data is what we want. So it is actually a cheaper solution. It's cheaper, it's faster as well because we are not storing a bunch of data in theme. So the index is smaller. When you do query in theme, it is even faster than before. But of course, you need to have your engineering team to build it because everything is in the data lake. The filtering logic is in the data lake. The ingestion pipeline is in the data lake. So you need to build yourself to maintain it yourself. So I would say it's a more advanced solution, but it's cheaper, faster. And then, yeah, threat hunting. We cannot talk about security data lake without threat hunting because threat hunting is what makes security data lake a security data lake. Threat hunting is a life cycle, is an experiment life cycle. There are many threat hunting framework out there, but the idea is doing hypothesis, having a hypothesis and you do the experiment and then refine your hypothesis. And in this process, you will improve your threat detection capability, the accuracy, the precision of your threat detection rule. Let's say, take an example. First of all, you need to have a hypothesis of your system. You may need to think about how bad your system may go. For example, you will have, let's say, you assume that maybe somebody will log into your AWS account, maybe the attacker use some stolen credential to log into your account. And then you will go into implementing a threat detection rule. How can I detect this threat? Maybe from CloudTrail logs, you can look for console login event and then see if it's legit login. So you start to write the detection rule to extract those CloudTrail logs. And then you will investigate the results. How many results can I get? how many false positive, how many true positive among them. Okay, let's say you realize after you getting a bunch of console log event, then you realize most of them are legit because your employees, your staff also need to log into the AWS. They are not attacker. So how do you filter this false positive? Then you will fine tune your detection rule. Maybe you need more data. Maybe you need to look deeper into your data. Let's say CloudTrail log has source IP. Maybe you can do a filtering. If the console login is from Office IP, then we don't we disregard it. We only interested on the console login that is from the unknown IP. Then at that point, you will refine your detection rule and then deploy it and do the experiment again. It's just like doing application development. You write the code first, test it, you find what's wrong with it. You have a different thinking, you refine it, deploy it. So you can see this life cycle. And this life cycle can be faster if you're using a correct architecture in the security data lake. You can make use of your data in a really fast fashion to do your threat hunting life cycle. And one of the key points we can make this threat hunting, a threat detection experiment faster is detection as code. It's just like infrastructure as code or a policy as code or whatever as code. The benefit is similar. So I will not go through it one by one, but just like better documentation. Nothing is better document than code. As people always say, show me the code. It's better to read code than just plain text description on how do you detect the threat, and it makes so many confusion and ambiguous. If you can write your detection rule as a code, then it's easier to understand. And also we can do GitOps, because if you write all the detection rule as a code, then you can put it into code repository. And whenever you change something, you can do code review as well, and etc. etc. So many different benefits. But what I want to share with you guys is what we use as detection as code. There's a quite famous threat detection language, I would say language, called Sigma. Is basically writing your detection rule in the same format, just like this. So you can see, let me make a laser point. Okay, I cannot, laser point. Okay, so you can see here, we have many different fields. Log source, provider AWS service CloudTrail. So this rule basically saying, I want to see all the CloudTrail log. And the detection is, we will select the source. So I want to see all CloudTrail log that event source equal to cloudtrail.amazon.aws.com. And also the event name is either stop logging, update trail, or delete trail. So you probably can guess what this detection rule is to detect any CloudTrail modification. Is there any malicious actor deleting the CloudTrail to prevent being logged? So you want to log this kind of event. So there are many different fields as well. But the beauty of Sigma is that you can write different backend for different service. Let's say you can write your Splunk backend or Elasticsearch backend. Once you have it, or you can download it from internet, there are some community member that write the backend for different purposes. But Splunk and Elasticsearch is the most common service that we use. So I use this as an example. Once you have the backend, you can run Sigma to translate the detection rule into different language. Let's say if you have Splunk, you want to deploy that detection rule into your Splunk system, it can help you to translate it into Splunk language, event source equal to CloudTrail, blah, 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 blah. Also, you can, the same rule can translate to Elasticsearch as well. So with Sigma, we can have a standard language, write all your detection code in a repository, and have your CI/CD pipeline run Sigma every time you have the change of the detection rule, and then it will translate to different language depending on what service you have, and just deploy it to different component inside your security data lake. So let's talk about our story. So I think everyone is waiting for this diagram, how we build the security data lake. So our story is starting when we are getting all the security logs we have to Splunk. And because we adopt more and more services, we spin up more and more system. We reach a tipping point that the growth of the security log is too fast that our Splunk license cannot catch up. So we have an idea on, okay, can we store our security log in other place without compromising our threat detection capability? And then we turn out having this architecture. The first thing we do is to find a data collector. As I say, the data connection is very complicated because there are many different log in terms of log format, ingestion method. So we find out some open source data connector and we customize it. But sorry about that, I cannot disclose what open source software we use. But there are quite a lot of open source software that do specifically ingesting logs, so you can explore yourself. And we use one of it and customize it. And then we use we run the application to ingest different log and send it to S3. So on S3 we have Athena. We built the Athena table for most of our security log. So our SOC security operations center team can query the log when they do investigation. When the incident come, they want to do investigation, they can make use of Athena to quickly query the data. We have Jupyter Notebook. Our SOC team or threat hunter will do their experiment using Jupyter Notebook to interrogate the data and find out some potential threat and write the rule. And once they write the rule, they will go to, you will notice there's a GitHub here. We store all our analytics rule in the GitHub repository. They will change the detection rule, deploy new detection rule, and save it into the repository. And the pipeline will kick in. We have Sigma to translate the detection rule into different language that can fit into the data connector. The data connector have the capability to filter log. So whatever security log that we are interested, they will forward to Splunk. So now Splunk, our Splunk is only storing some interesting data that we think have potential value for further analytics. So the same analytics rule will also translate to Splunk language and deploy to Splunk. So we have one single repository to do analytics and alerting. Is very useful because we have a single source of truth. No matter it is an analytics rule or real alert rule, we are storing in the GitHub and use the same CI/CD pipeline to deploy it into different components of the data lake. And also, as I say, data lake is a single repository of data. So whatever you want to do to the data, you can rely on it. So we have different teams. We have data team, we have machine learning team. They also want to play with our data. So we use S3 access point to easily control the access on our data with another team as well. So this is pretty much our technology we use and the architecture we have. But technology aside, I think the company, or more importantly, the people, is also the success factor of building a successful security data lake. So our company have a dedicated SOC team, a security operations center. They have threat hunter. They will do security incident response. So they are the best people to understand the risk landscape of our company. They will spend their time to do threat hunting, the threat detection experiment. As I say, the life cycle of threat hunting. They are constantly doing this kind of experiment. So they are the one to use the security data lake mostly. And we have a IT team. IT team is important because when you want to know how many data your company has, most likely the IT team can answer you because they are the one to handle all the components. They can answer you how many components the company is. So ask the IT team, how many components, how many AWS account we have. Then you will have a clearer picture on how many security log you will need to ingest. Security engineering team, which I am part of it, is a dedicated engineering team specifically built something for security. So we have a dedicated team, so we can dedicate our time to build our security data lake, build our custom solution. But if you don't have a security engineering team, it's also fine because, as I say, SIEM and security data lake is not mutually exclusive. You can start figuring out your data with the help of SIEM first, and then you can start your experiment on how you can make use of your data. You can find your data, you can find your custom use case based on the SIEM. So you can start from SIEM first. Cross-team collaboration is also important because the security log is from different teams. We are protecting the company, not protecting yourself. So you need to protect your application. You will need the application team help because in order to help them protect their system, they need to onboard their data. They need to onboard their security log to you. So you need the cross-team collaboration. You need to build a relationship with the application team for you to successfully grab all the security log into your security data lake. And also the security knowledge of your application team is also important because when I was a system engineer, I want to onboard the security log to the application team. Every time I reach out to them, I will got rejected by them because they think the security log is not important. Their feature is more important than security log. So every time I need to chase them. But in ExpressVPN, because our application team, their team member have some security knowledge, they know what is the potential threat of their application. They know in order to mitigate it, they need to onboard security log. So right now they are chasing us to onboard their security data to us. It's also a pressure to us, but I'm happy to take this pressure because I'm no longer the one to chase them for their security log. But on the other hand, they are eagerly to give the security log to us. So yeah, it's really very interesting. Yeah. So some takeaway. If you want to start building your security data lake, or not even so far away, if you want to start collecting your security log, first evaluate your current state. Where do you store your log now? Are you using SIEM? If not using SIEM, most likely you don't need a security data lake now. Find out how your data looks like using SIEM first. If you're using SIEM, then you can play around with your data. Don't just store the data in SIEM just for storing it. Play around with the data and know how your system behaves and how your system may go bad, how your attacker can attack your system. Play around with the data first. And then what skills do your engineer have? Do you have enough bandwidth to build your solution? If not, then maybe stick with SIEM first. Maybe if you have extra bandwidth, you can play more customization and start small. Start ingesting the data that you can get easily first. Evaluate how you can use this data. Don't try to ingest all the data and later figure out, okay, my indexing is wrong, the access control is broken, and then you need to do it again. Start small. Do the whole life cycle on one data source first and see how it works. And also estimate the cost is also start small. You need to estimate the cost because with a huge amount of data, the cost can always surprise you. And one of the mistakes I made is be careful of data transfer cost. It may surprise you because many people just don't care about data transfer because the use case is negligible. But now you're talking about ingesting data, so the data transfer cost can be huge. One mistake I made is I didn't use VPC endpoint, and then I send the data to S3 through internet. and
Ooh.
that cost is using Net Gateway. It is
Yeah.
really expensive. So
Yep.
care about the transfer cost. Also, be careful on the data. Is it compressed or uncompressed? Because this will significantly affect your transfer cost. If you are estimating your cost using the compressed size of your data, most likely you will underestimate your transfer cost, because transfer data, most likely they are uncompressed. So this is also one of the mistakes I made during my project. Embrace infrastructure as code and detection as code. So maybe it's painful at the beginning. You may say, I can easily deploy my Elasticsearch query into the Elasticsearch, I forgot what that is, the Kibana, or the UI, the Elasticsearch UI. Oh, why I need to write the code? But believe me, it will pay off when you have more and more people working on it, and you don't need to explain to your colleague on how this works, because show them the code and they will figure out. And you can have a centralized repository to store all your infrastructure and detection, and you can easily copy it, and it will reduce and save so much time when you go along the way. And also don't forget about people, because no matter how you structure your architecture, your company structure will always reflect it in your architecture. So if you design architecture that onboard data in this way, but actually you work with the application in that way, so they will not fit. The process you design will not fit into your company culture. So you need to think about how your company work, how different teams work together before deciding what architecture you need to have. And also build a good relationship with different teams, because as I say, they are your data source. If you don't build a good relationship with the application team, they will not give the security log to you, and you will end up building a security data lake without data. So that's it. Go and collect your security data log. Don't regret you don't have any logging until you are under attack. Yeah. Thank you.
Awesome, Richard. This was an excellent presentation. A lot of the talking points really resonated with me. In prior lives, I've been the person trying to figure out costing. So you're estimating costing, embracing infrastructure as code. All of those things are very, very relevant in a cloud-based organization.
Yeah, that's true.
Dumping all of your. I had one customer that dumped all of their, just like right out of the gate. I was like, okay, what do you want to send up to Datadog? What do you want to send to your SIEM and everything? They're like, everything. I was like, okay. And then that first monthly bill came in, and they're like, whoa, wait a minute. Okay. So yeah, it's something that can certainly bite you in the butt if you don't figure out how to leverage it. And of course, making sure that you're protecting your sandbox as well as your production environment, because if your sandbox or your UAT or your development environment gets compromised and you don't know it, that's a very short hop to injecting a dependency into production. So this
one of the biggest mistakes I've come across is not to monitor it. Yeah, that's true.
Yeah, it's this was an excellent presentation. Let me check real quick to see if anybody's got any questions. I don't. I was nodding along with you the whole time. I was like, yes, more of this. So I fully agree. I don't have any questions, but let me check the Twitter real fast. And ChatGPT is sentient. Nope, I don't have any questions. And we got some comments from the group. They are all agreeing with you as well. Yep, cheap to get data in, very expensive to get data out.
That's why we want to build the customized solution, because if you send the data, if you rely on the SIEM solution to store your data, and one day they change their policy, and you're gone, your data is logged into to them. So it is important to own your data, own your data in your data lake. Don't rely on storing your so critical data in other solution.
Exactly. Awesome. Well, cool. Well, Richard, thank you very much for getting up early for this presentation. I really appreciate you coming on from halfway across the world. It is 9:30 p.m. my time, so that means it's 9:30 a.m. your time.
And the next day.
So yeah, and the next day, yeah, it's the 30th there for you. So
yeah, that's true.
Cool. Awesome. Well, have yourself a wonderful morning. I will go have a wonderful evening, and thank you everybody for attending another show.
And thank you for having me.